So we've talked about exponential growth and population growth, but we can also talk about exponential decay. So when something is decaying. And if you've ever heard of carbon dating, how scientists can tell kind of how long ago something lived, this is one way to do it. If they can study how much of the carbon has decayed away. So here the function p of t equals p0 e to the negative kt, where k is still positive. But here you'll notice we have a negative value there instead of a positive, is our decay. And k is called the decay rate. And when we talked about, instead of talking about doubling time like we did for populations that were growing, we can talk about half-life. How long does it take for half of it to decay away? And just like we saw for growth, the decay rate and the half time are related. We have these formulas. They look very similar, same thing. And it doesn't depend on how much you started with. So here, if we start with P0, we want to know, well, how long does it take to get to 1/2 P of 0? And just like with doubling time, the very first thing we're going to do is divide both sides by P0. So we'd have 1/2 equals e to the negative kt. Well, if we take natural log of both sides, we'd have natural log of 1/2 equals natural log of e to the negative kt. And remember, natural log and e cancel each other out, so we're going to have natural log of 1/2 equals negative kt. Now, natural log of 1/2, that's division. We can break it into two logarithms, natural log of 1 minus natural log of 2. And natural log of 1 is equal to 0. So that gives us negative natural log of 2 equals negative kt. And we can divide both sides by -1 to get rid of the negative. So we'd have natural log of 2 equals kt. So that's how we get this first expression. If we solve for k and we use a big T for half-life, we'd have natural log of 2 equals kt. So if we solve for k, we divide both sides by t, and we would get this expression. And then if you solve for t, you'd just be dividing both sides by k, and you would get this expression. So they all come from the same place. It's just which variable you're solving for. Okay, so we'll do a problem about decay in the next video. But here you see that the only difference is we'll have a decay rate and we'll put a negative sign in front of it in our formula.